星舰10啊，这次发射是圆满成功。大家好，欢迎回到宋时新语。推迟了2次之后啊，Starship 10啊，就星舰10的发射 ，IFT 10的发射呢，终于取得了阶段性的成功啊。那这次呢，应该说干净利落啊，各项任务都完成了。而且呢，这个应该说呀，在降落阶段，这个悬停各方面都是比较完美的。我们先看一下视频。那这个视频啊，我这次做的时候呢，我是把字幕和我的头像都放到上头了，做一个 reaction， 因为下边呢都是飞行的数据，是吧？我们现在开始。
All right, so we've got crowds gathered out at Hawthorne, crowds gathered here at Starbase.
Super fun to see people getting to watch out on the front lawn now.
1 minute to go to launch. All right, so again, our hold point comes up at T-minus 40, not tracking any reason to stop there, so we should see us go right through that. All right, we are through T-minus 40. We are counting down. We're going to let our flight director, Maciek Batura, take us the rest of the way. 30 seconds, the 10th liftoff of Starship.
好，这一次倒计时算是比较顺利啊。通过了 T40，停留点没任何问题。我们经过2次推迟之后啊，这一次流畅的倒计时，到我们都松了一口气。好吧，10、9、8、7、6、5、4、3、2、1，发射！
Vehicles pitching downrange. Booster chamber pressure nominal.
这个发射初期啊，火箭跟不动一样，以为停了呢。这个发动机是完美的都点火了。
Over 40 seconds into flight, 33 out of 33 wrapped engines.
Power and telemetry nominal.
Getting good call outs, healthy systems on the booster as it starts to pitch over the Gulf. All right, we're a little over 1 minute into flight, about to pass through max Q.
Max Q.
这个有一个最大动压点，就是 Max Q 啊，这个是一个很关键的节点。火箭呢，在这个上升过程中啊，要承受这个空气动力压力最大的时候啊，所以还是很顺利的。
The booster will shut down all but 3 of its Raptor engines. The clamps holding the 2 stages together will release, and the Starship second stage ignites its engines. The ship then separates from the Super Heavy booster and heads to space. At the same time, the 3 engines still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on the path for splashdown in the Gulf. As we mentioned earlier, the hot stage will be jettisoned for this flight, and that should occur just after the boost back burn. So we're about to shut down the first stage and perform hot staging. So let's just watch and listen.
就是星舰分离。那么 hot staging 呢就是星舰的上级吧，就是 ship 与助推器之间呢没有完全分离的时候呢，就点燃了自己的发动机，把自己推离这个助推器，这个画面还是很震撼的。
All right, seeing the engine start to throttle down.
Miko. Ship ignition. Boost back burn startup. Stage separation.
分离了，看到了吧？这是很关键的一个点。
Stage separation confirmed. We've got 6 engines running on ship. Booster is doing its boost back burn, continuing now towards its splashdown site in the Gulf. We are seeing all 6 Raptors lit up on ship. You heard them report ship chamber pressures nominal, so that chamber pressure, just that expected thrust level in those Raptor engines on the ship. 3 vacuum optimized, 3 sea level, all looking good. There's a view into the business end from the ship.
2 spec burn shutdown.
大家现在看到画面下边的2个圆圈啊，2个仪表盘，左边是火箭的，就 Super Heavy 的，右边呢是星舰的。星舰的发动机呢都点着呢啊，那么火箭的呢，它没点，一会儿还要再点，冲入大气层会点。现在高度是火箭是85公里啊，
We relax that angle of attack a little bit, but we are then going to be looking for it to do its engine tests for the landing burn, and those are going to be a little unique this time.
Yeah, typically we start with all 13 inner engines lit for that landing burn and bring that down to just the center 3. But one of our test objectives for today is to simulate what an engine out situation would look like. So we're going to be intentionally turning off one of those center 3 and instead lighting one of the engines from the middle 10 ring.
Yeah, we did see one of those engines in the middle ring shut down during the initial ascent. Oh, looks like we have hot stage jettison. You can see it floating away there to the left of the booster. Yeah, we did see one of those middle engines shut down during the ascent. Again, we are resilient to engine out on Super Heavy. That's why we're able to get through our ascent. Starship flying on the expected path. There's still a chance that engine could be back in the mix for the very start of the landing burn, so we'll see if we light up all 13.
刚才这个咱们提到啊，它这次有一个独特的这个着陆燃烧测试，这是这次任务的一个大亮点啊，就是助推器在进行这个着陆燃烧的时候啊，会故意关闭一个中心发动机，哎，启动一个外环的发动机来替代。目的呢，就是为了模拟有发动机发生故障的时候这个着陆情况，这是一个非常都是超前的测试啊。这个应该说 SpaceX 啊，在这种真实的飞行中测试这种极限故障模式，那这是一种硬核的做法啊，这样在飞机上是不可思议的。
Right, about 20 seconds to landing burn.
现在距海面6000米，
Ship Raptor chamber pressure is nominal.
再经过云层啊。
All right, here we go.
哎，点火，发动机整个这一圈全点火，看到了。
Looks like we got 12 of those 13.
他做这个发动机的这个，现在500米已经到海面了，400米。大家能看到这个波涛了，是吧？来看这画面啊，实际上它是很稳的在下降的，300米
，200
米。100米已经到海面上了，看这个波浪水已经被吹开了。这个状态下，大家这样侧着看，它是很平静的悬停状态，好吧？这就是第一个任务啊，Super Heavy 的这个回收啊，是非常成功的啊。用快子夹的话呢，应该也没有问题。现在呢，就只剩下星舰的任务了。
Meanwhile, back in space. About 7 minutes into today's flight, ship continuing its ascent burn. This goes until just about 9 minutes into our flight. That ship engine cutoff is slated for 8 minutes and 57 seconds. We are going to see those 3 RVAC, the Raptor vacuum engines. Those are the bigger circles in that little indicator on the bottom right of your screen. Those will shut down first. And we continue burning for a couple seconds longer on those inner 3 before we hit SECO, or second engine cutoff.
Yeah, these views are looking great. Once again, thanks to Starlink for getting us these views. It's just incredible. And we just heard the sound from Booster.
It's like we just got a late boom from the booster.
Yeah, we have ship engine cutoff coming up here just shortly. And as we mentioned, today's flight test is not an orbital flight, but rather one that demonstrates Starship's orbital capability.
Starship is in terminal guidance.
All right, entering the final phase of this burn. Under 30 seconds to go. All right, shut down the vacuum engines.
Ship engine cutoff.
We shut down those center three. Successful ship engine cutoff.
Seco, baby. There we go. That's what we want.
Nominal orbit insertion.
All right, we just heard the call out for nominal orbital insertion.
现在星舰的时速是26489公里每小时，换算成秒的话呢，大概就是7公里每秒左右。
Space. There we go. We're seeing the flaps starting to move into a stowed position. That's why it looks like your camera's moving.
Yeah, exciting to see Starship safely in space and super pumped to see all the team's hard work in action here today. And of course, as guaranteed, it's been an exciting day so far. We successfully lifted off right on time at 6:30 p.m. Central Time. Thankfully, our weather was looking good today. Yeah, and booster, we had our soft splashdown in the Gulf, so ship continues on.
Yeah, ship able to complete its ascent burn all the way in. You can see some of the shadows start to creep as it's going to be eventually flying into an orbital nighttime. So we'll see some daylight start to go away. But ship is in orbit, completed its burn, and
就这个算是仅翼吧，有明显
now
的
we've
这
got
个
a
损伤
whole
和
bunch more to go.
这种
So
烧蚀
we've
的痕
got
迹
some
啊。
exciting demonstrations
Ship
planned
FPS is
while
safe.
we're on orbit. That
而
right
且他
there, we
们
just
这次
saved
呢
the
是还是有
FTS, the
点比较
flight
苛刻的
termination
测试的，
system. That's that automatic flight safety
就是
system we have on the vehicle.
做出一些
So
剧
that
烈
is
的
now
机动，
turned off
测试它的
while
结构
ship
和
starts
防
its
热防护
coast
的极
period.
限啊。
We are coming up.
这次
Our
呢算
next
是极限
milestone
测
is
试。
going to be the deployment of those Starlink simulators. We've got some payload inside of Starship that we're hoping to deploy into space for the very first time. That
尽管这
deploy
个
is
仅翼
supposed
啊
to
烧
start
蚀
at
甚至
about
烧掉一
18
块
minutes
啊
and
但是
27 seconds
这
into
个
the
姿态控制
flight.
还是很
So
准确的
just about
说明什么
7
呢？说
minutes
明
from now,
这是一个完全
that
自主
deploy
的
will take
控制，不
place
是人
over a
在
couple
控
of
制
minutes.
啊，就
It'll
是
go about one
飞行计算
satellite
机
a minute.
在控制。
So we'll be spread out over that. It might get a little dark, but we've got a couple of views that we can show you to see that deploy in action. After that, we're also looking to do a relight of a single Raptor engine while we are in space. We've done this once before. This is not necessary to deorbit as we are in a suborbital trajectory, but this is essentially a chance to test out
这个
what
假
we
卫
need to
星
be
马
able
上
to
就要
do a
部署了
deorbit burn.
啊，
So we'll be doing that a little bit later in the flight, about 37 minutes or so into the flight.
就是有8个星
And
链
then we
的
get
模
into
拟器，
reentry.
哎，
We're
就是
looking to get that light
像那
show
个
and
子弹一
more
样压在的
importantly,
这
get
个
that
发射
really
器里
critical
边，
data
一个一
about
个
the
弹
ship's
出
heat
去。
shield.
它实际上是
Yeah,
一个
exactly. At
皮带轮
about T plus
加一个
45
垂直的导轨，
minutes,
就
we'll be
三
heading
项
for
运动，把
reentry.
一个一个
Again,
推到这
running
门
those
口，把它推出
experiments
太
with the
空。
tiles. We're going to be doing missing tiles, metallic tiles, and also intentionally loading those vehicles' flaps. Hopefully, we'll also see a splashdown in the Indian Ocean today.
Yeah, we were able to get to a reentry last time, but we didn't have full attitude control, so we weren't able to go in, heat shield first the way we're designed to. So we ended up losing contact with the ship before we could make it all the way through. So you still get data, but you're not really getting the data that we want to make sure we're kind of stress testing the vehicle. As Amanda just said, we removed a bunch of tiles, and we do this in some intentionally scary places on the vehicle because we're really looking, are there spots that were vulnerable to this before we ever start moving towards, putting ship into a full orbital mission to then do reentries a little bit later on. So really, really critical to get that data, really looking forward to a controlled reentry.
Yeah, for sure. As we always say, our main payload is data. But today we also have some actual payload on board, and those simulators that Starship will be deploying, we'll see coming up here in just a few minutes. These are dummy satellites that are about the same size as our V3 Starlinks. We have 8 in the Starship PEZ dispenser and expect to deploy at a rate of about 1 per minute, as Dan mentioned earlier. Starlink is critical in all of our flights on Starship to get our main payload, data, as we always say. And in fact, it's Starlink that's currently providing these views you see as Starship cruises a couple hundred kilometers above our home planet and provides real-time telemetry through every phase of flight.
Yeah, we took a peek inside of the Starship payload bay there for a second. So there's 8 of them there. They kind of look just big steel plates, essentially. They're roughly the same size as those V3 satellites. When we do get that view inside of the payload bay, the payload door will kind of be on your right, and we'll start to see them go out like a PEZ dispenser. Yeah, here's a look inside. So those right down there in the center, they're kind of 2 stacks of 4 on either side, and then the payload door is just to their right. And so we'll look to see that open, and then those satellites start to go. We vent the nose cone, so we essentially bring it down to vacuum before we open the door. That was one of the things we ran into on the last flight, as when we had that fuel diffuser fail, the pressure in the nose cone became basically too high for the actuator of the door to open. So that's why we weren't able to get the door open that time. We have not seen anything like that on this flight. Everything's looking good with our fuel tank and our fuel press system. So we are hopefully just a couple of minutes away from seeing that payload door open and getting to our first ever payload. It's not the first payload we've ever carried.
哎呀，下楼接杯水，这有效载荷已经开始部署了。
Shoot off into space.
大家看到了，上面是2根导轨，这个横着导轨其实就是一个3个维度的这么一个运送装置啊。因为它堆垛嘛，一个一个把它推到那个有效载荷口，把它推出去。这两边是那小链轮，应该是皮带轮，不是链轮。
When we were able to make it up into space, and you'll kind of see a lot of that gas rushing out into the vacuum of space. It's the residual that's left over after we've already vented it down. So kind of a cool light show, and then we'll get ready to deploy those payloads out. And as we mentioned, so we have crossed over now at this point into an orbital nighttime. So views from the outside will get pretty dark, but we'll see what we can see. We do this by design. We've been launching these later in the day here in Texas to try and get daytime views when we splash down. So it's daytime over in the Indian Ocean, where we are currently headed.
Just a few seconds until we expect those payload doors to open.
All right, one more time. Open the pod bay doors, Hal.
每开一次舱门啊，这个压力都有很大变化，所以这里边的气体也都有变化。
So we are currently in payload deploy prep. And the door is
大家看到
All right, so the payload door is open. We should see the first satellites start to deploy at about T plus 18 minutes and 27 seconds. So should be only about 30 seconds. So one step closer. Hal listened this time. He cooperated. He opened the payload door for us. There's a view kind of behind the Pez here looking out into the vacuum of space.
About 15 seconds until payload deploy.
Ship has transitioned to payload deploy.
它现在是一个应该是个360相机，不知道它用的是 Insta 360还是 GoPro 的360。
There we go.
"成功的发射了一个卫星模拟器啊！大家都看到是一个，其实就是一个升降横移的这么一个传送系统，和我们的立体停车库是
Been
很
waiting
像
way
的。
too long to do that. There we go.
There goes another one. Super exciting moment, as you can hear the energy in both Hawthorne and Starbase. Everyone's super excited for finally getting to deploy some of those simulated satellites.
Pez system moving down. Next row. There we go. As we said, we're going to do about one every minute or so. And this is just kind of a dress rehearsal for when we're going to be deploying the V3 satellites. And these are just a massive, massive increase to Starlink's capability. Each one of them has it's 60 terabits per second of capacity that's going to get added to the network per launch. That's 20 times more than what we're adding with every single Falcon 9 launch today, which, you know, step increase in capability. There goes another one. All right, so as we said, we've got 8 total that we're going to go through today. It's about a minute for each one, but looking good on payload deploy. All right, so we're about halfway through. When we actually start launching the V3 Starlinks on Starship, we're going to be flying about 60 each time. So it'll be about an hour to get through a full stack. But again, it's just going to be a massive increase in the amount of bandwidth. It's going to enable, you know, gigabit upload download for people with Starlink, you know, anywhere on the planet. And for us, Starlink is just a tremendous part of just the Starship flight test program.
Yeah, absolutely. Always getting us that data, and yeah, the amazing views we have on the vehicle today.
Yeah, views brought to you by Starlink of us deploying Starlink simulators before we deploy actual Starlinks. How deep does it go? All right, another one firing out. Pez looking smooth today. All right, looks like we've got one left.
Almost there.
Yeah, there you go. One remaining, so 7 of the 8 have been deployed. One more to go. And then we will have completed our first ever payload deploy operation. Just a reminder, we're on a suborbital trajectory. These satellites on that exact same suborbital trajectory, they're going to burn up entirely and are on that same trajectory towards the Indian Ocean. So the last one has been deployed. Starlink simulator payload complete. Heck yeah, everybody.
Loving the energy from Starbase and Hawthorne.
There, yeah, now it's empty. Looking a little lonely, but
Successfully deployed all the simulator satellites.
really, really cool to see them all out there. Again, people that have followed know Starlink's really critical for the Starship program, in addition to, getting all those views back from the cameras on Starship, which this is an external view. As I said, it's dark outside right now. The lights are off, so it's going to be hard to make stuff out. But in a little while, the sun's going to start coming up as we get to re-entry, which is going to be really critical. We use Starlink for Starship data. Cameras also use it on the cameras that we use to bring you views of these launches and also, hopefully, of the re-entry and splashdown. We'll see what we get from the Indian Ocean today. And that's just kind of how it all comes together. Like, we're using Starlink on the planet, off the planet. And with Starship, we actually get pretty insane. If you're in the space industry, bandwidth to space is usually pretty minimal. We get about 120 megabits per second. That's split between our high-definition video and real-time telemetry. We get that every phase of flight, including re-entry. So it's not just giving us views of re-entry, but we're getting all of that engineering data in real time through phases that it used to be impossible to get that in real time. So just really incredible.
Yeah, Starlink definitely affords us all this capability. And reminder, it's the world's largest satellite constellation operating in low Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people all around the world, many of whom had never had connectivity before. Today, Starlink serves more than 150 countries, territories, and other markets, with over 6 million active customers and counting. To meet the growing global demand for high-speed internet, SpaceX expanded its factory in Bastrop, Texas, and also introduced Starlink Mini, as well as an upgraded version of the Starlink Standard kit.
All right, now with payload deploy complete, Starship is now going to close its payload bay door and continue to coast towards Earth, around Earth, towards the Indian Ocean. Sorry, I'm really excited today. We are in space, people. Still a lot of major events to come, though. We are looking to relight one of those Raptor engines at about 37 minutes, 33 seconds into the flight, followed by atmospheric entry, hell of a light show, and splashdown. So we're going to go on a quick break, take a quick coast, sit back, enjoy the views. A little bit dark now, but they'll get better soon. couple of space jams. We'll be back in just a few minutes for that Raptor relight and then re-entry. See you soon.
马斯克这么公开发射，包括内部结构，是不是有点危害国家安全？你们觉得呢？泄密吗？这不是？刚才呀，就这些飞行的小白点啊，它不是碎屑啊，不是说这个部件掉的渣是吧？渣不是渣，它是就是 venting 啊，就是应该叫排气吧，放气过程中产生的这个冰晶。大家知道这个假卫星往外，就是右边这一侧往外发射的时候啊，实际上里边是真空状态的，所以这些残留气体啊。往往需要在这个压力平衡啊，或者磁带调整的时候呢，包括刚才说的这个模拟卫星这个门打开的时候，把残留空气排出去。这些空气里边可能有微量的水蒸气啊，那么被排放到这个太空啊，这个真空和极低温环境的时候呢，这水蒸气就会瞬间的凝结吧，就算凝化，从气态直接变成固态，就形成那些无数的小冰晶。所以在这个灯光下反射呢，就嗖嗖的，它实际上不是渣啊。
All right, welcome back, everybody. If you're just joining us, Starship just successfully deployed its first ever payload. We got 8 of those Starlink simulators out, and now we are expecting the relight of a single Raptor engine. That should be coming up in just a little under a minute. We're going to be lighting just one of those Raptor sea levels in the middle there. This is not a deorbit burn. It's a demonstration of what we'll have to do for deorbit burns, but we've done this once before. This is something we're really going to have to do when we're doing orbital missions, so it's a pretty critical test. We are just a couple seconds away. Sorry, we're about 20 seconds away, psych. So we got a little bit more time. So we are going to see one of those Raptor engines light back up. We are through the deorbit demo gate, so we should be seeing it momentarily.
Relight demo startup. And shutdown.
All right, looks like we confirmed the relight of one of those center Raptor engines. Second time we've done that. Super exciting. Huge congrats to the team on this milestone. Very exciting to see.
That was a cool light show. Yeah, I get to do a mini version here. So again, that's going to be really critical for when we're doing deorbit burns. Like as you're going through, which if you don't have one of these, my God, they're so much fun. But like you're able to actually like light. Oh, man. Dan, turn it on. Light that engine. Not set my co-host on fire. And that's what we'll eventually do to, break out of orbit, come back down to Earth. So really cool to see one of those engines light back up again in space. That was our last in-space thing.
Very exciting. We're going to be heading back for re-entry at about T plus 45 minutes. So we're going to take another quick break, and we will see you soon.
大家看镜头下边这个2根棍子，它因为是广角的原因，就是摄像头啊，广角摄像头呢，相当于360摄像头吧，它在这一臂上，所以呢，理论上啊，就是这2根啊，最下边这2根粗的这个像导轨一样的东西和下边那2根，就是屏幕中间的，包括屏幕顶部的那2根，它都是平行布置的。
Starship is slowing for entry. Starship is approaching entry interface.
科幻永远还是科幻啊！现在飞船的速度是每秒钟应该7公里左右，所以你想用曲力引擎也好啊，用更高速度的发动机啊，都是在这个化学燃料发动机基础上一步一步发展起来的。现在这颜色是非常漂亮啊，就是飞船现在就被这个粉红色的这种应该叫等离子体包围吧，非常壮观。就载入的时候，你看这么恶劣的环境啊，我们能看到这么清晰的这个图像，就是因为星链啊，它这个高频信号能让我们在这个载入这个黑障区的时候啊，全程保持高清的这个视频和数据回传。这在航天史上是前所未有的啊！大家知道黑障吧？
Has begun. We are starting to re-enter the Earth's atmosphere. We're moving about 5 times the speed of sound, and we're about to start barreling through the Earth's atmosphere and head for a splashdown in the Indian Ocean. We don't plan to recover the spacecraft today, but if we do make it all the way down to the water, who knows? But the goal of this part of the flight is to learn as much as we can about the ship's heat shield. A fully reusable, rapidly reusable heat shield for a spacecraft has never been done before. It's one of the hardest engineering challenges still out there for us. And so this is a time to really dig in and get that data.
Yeah, absolutely. And re-entry is a critical phase of flight, so we'll need information on how the ship's system end up performing. And Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests. Starlink provides us with one more path to collect data to help us rapidly iterate on Starship's design. And if the ship manages to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds or more than 5 times the speed of sound.
Yeah, throughout history, a lot of times this is when you go into just a complete data and insight blackout, where that plasma sheath builds up around the outside of the spacecraft that blocks all of your signals that are trying to fight through to talk to either satellites out in space or towers down on the ground. Starship's big size kind of gives us awake, but What really helps us punch through is the fact that we're using Starlink. We're operating at just a much higher frequency. That's not what we want to see. So we just saw some of the aft skirt just take a hit. So we've got some visible damage on the aft skirt. We're continue to re-enter though. And again, we are intentionally stressing the ship as we go through this. So it is not guaranteed to be a smooth ride down to the Indian Ocean. We've removed a bunch of tiles in kind of critical places across the vehicle. So seeing stuff like that is still valuable to us. We are trying to kind of push this vehicle to the limits to learn what its limits are as we design our next version of Starship. So 47 minutes, 45 seconds into the flight, excitement ticking up a little bit on re-entry already, but the light show is continuing. This re-entry is going to take about 20 minutes or so until our planned splashdown. We were trying to splash down about 1 hour and 6 minutes into the flight.
Yeah, and one day Starship is designed to land on Mars, where there are obviously no runways or other humans to help us out. So we are doing propulsive landing instead of more traditional means such as parachutes. And propulsive landing enables us to have more rapid reusability with these vehicles.
Yeah, the ship itself, it's a little over 50 meters tall. We've got those 6 engines on board, the 3 vacuum, the 3 sea level, and they're down in that aft skirt region, which
flaps have control.
All right, so at this point, the flaps have control. That means we're getting into a dense enough part of the atmosphere that the flaps can start controlling us. We're not only reliant on those kind of reaction control system thrusters.
We're going to continue hearing some callouts as the ship makes its way back to Earth. So when we hear entry max heating and entry max Q, that will mean the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through those, we can say we're doing pretty well.
I will say I'm happy re-entry cleaned off this camera for us. It was a little dirty from the weather, so thank you, Plasma, for giving us this view as we start coming down. The hit we saw to the skirt, definitely interesting. I will note, when we started doing these missing tile tests, we were intentionally removing them only in the skirt, as that's, that's not over your fuel tanks or anything else that's kind of structurally critical for keeping the entire vehicle together. That obviously exposes your engines, so that could do some things for our landing burn, but for now, we are obviously continuing with this re-entry. We are committed. Indian Ocean, here we come. 50 minutes since launch. We're going to see those colors start to build up a little bit. We are at the point where we're in dense enough atmosphere that the flaps have control. So about 74 kilometers in altitude. And you were starting to see some sunlight, so we intentionally time these launches right now so we have daylight. The sun should actually come up over the horizon on Starship in about 3 minutes. So as we get a little bit further into this re-entry, that inky black below you is going to start to look like clouds and hopefully a bright blue ocean as we make our way down onto the other side of the planet. We've got these cameras. These cameras are really cool. We added these several flights ago, looking directly at the flaps as not just the heat shield, but these flaps, how they're able to control the vehicle, withstand that re-entry, the seal locations, so kind of where they connect to the ship itself are some of the most critical. We will do missing tiles on those where, again, we're trying to... We're kind of being mean to this Starship a little bit. We're really trying to put it through the paces and kind of poke on what some of its weak points are. I mean, we even have missing tiles over some of those fuel tank sections of the ship itself. And so we're really trying to see what are our limits. We're doing this over a completely empty area over the Earth. Look at our Raptors there. We are assuming we make it all the way down to the ocean in one piece, we will attempt a flip and a landing burn. We do have at least one buoy, everybody's favorite camera person, out in the Indian Ocean right now, being powered by Starlink. So that's at our planned landing location. So if we're able to get any live views of the ship, that'll essentially tell you that we nailed our target. Able to do that on our 6th flight test, do it in the daytime, which was really exciting. All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones coming up.
Yep, in about 10 minutes, like Dan said, Starship will be transonic. This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85, so that's 480 to 575 miles per hour or 770 to 930 kilometers per hour.
Yeah, and after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now. But by the time we hit subsonic, we're essentially belly flopping down. There we go. There's that sunlight. So we're seeing the Earth now come back into view. One of the other things we're doing during this, and you're going to see Starship kind of pitch in some pretty, not extreme ways, but a little extreme, as we're trying to really stress the structure of the ship itself, specifically those aft flaps. So the ones in the very bottom of the vehicle. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are pushing it beyond essentially what we think we'll have to fly at to do something like a return to launch site. So again, may not be a very smooth ride downhill, but we're doing that by design. We're really trying to find what are the edges that we can operate at, build up a good data set. But sun is up, clouds and water down below us. We are just about 10 minutes away, a little less than 10 minutes now, until we start hitting transonic and then subsonic. Once we hit subsonic, we're basically just belly flopping. All right, so about 55.5 minutes in, you can see the sun is up. Again, we intentionally designed these flights to lift off in the evening here so we get these daylight views so we can get as good a video as possible on the ship, assuming we make it all the way down. We've got at least one buoy powered by Starlink that's out there in the landing zone in the Indian Ocean, hopefully giving us a view again. If you see any live views, not from the ship itself, that means we nailed our landing target.
Starship is past peak heating.
All right, we just heard the call out that we're past peak heating, so things are looking good so far.
Yeah, looking good. And at this point, again, the flaps are controlling. So this movement you're seeing is that forward flap moving to try and just maintain control, maintain attitude of the vehicle as we're coming down.
星舰刚才的速度啊是26000多公里啊，就是很快的。这种速度呢是
In on one of our
超高音速
flaps.
穿过大气
We
层的
got
时候
one of
啊，
these
它
cameras
前面的
on
空气
all
呢
four
会
of the
被极
flaps,
限
two
的
in the
压
front,
缩，
two in the back,
产生很
giving
大的
us
这个摩擦力，就电离的
really
空
good
气。
close-up views. As we obviously don't have a camera that can see the entire heat shield. These give us kind of the best that we can do. But looking at those flaps is really, those are just, super critical for controlling the ship. You have some ability to maneuver kind of cross range. So as you're coming in, you can see in that indicator at the very bottom right that we've pitched up quite a bit. So again, we are maximally stressing those aft flaps right now. Looks like we got a little bit of burn through the very bottom part of it. Everything's still looking good. Ship maintaining control. We should be just about 5 minutes away until we hear that we're transonic. Still a little bit toasty on the aft skirt of the vehicle as we continue coming in.
Again, we are intentionally stressing the flaps so we can learn all we can.
All right, so now we're already well past peak heating. Just about 48, 49, counting down to 48 kilometers in altitude. Expecting that transonic to come, so transitioning between the speed of sound and subsonic slower than the speed of sound in just a little under 4 minutes from now. And right now we've got kind of a lot of forward momentum, a lot of forward velocity, and then eventually by the time we hit subsonic. All right, here we go. So this is what we've been talking about, where we are going to essentially try to fully deploy those aft flaps and really stress them out. So again, this is meant to test the extremes for the vehicle. All right. See those flaps swinging out? Again, we're putting ship through the ringer on this flight in. It's like we're still maintaining control. All right, flaps earning their paycheck today, getting through kind of that max stressing.
Definitely things looking good so far. We're about 2 minutes out now from Starship becoming transonic.
One cool thing to note as we get some of those views showing kind of the whole length of the ship, one of the changes we made after Flight 6 was to change the tile line a little bit. So we had kind of scaled back the number of tiles significantly, as when we go to catch these ships, you don't want to, I think as Elon said, you don't want to shuck the ship as you catch it and knock all those tiles off. So we knew we were going to have to kind of peel back that layer a little bit. And the first time we did it was on Flight 6, and we saw kind of wrinkling and dimples almost in the ship as we were creating these hot spots in the uneven parts of the heat shield. And so to kind of address that, we smoothed it out. That's why you've got kind of that nice smoothed out black line now on the ship. And just looking at it, we can see kind of a little bit of hot spot, a little bit of warping almost. Near the payload door, you can see a little bit of colored patina up above it, but we don't see those kind of deep, almost, they almost look like gouges on that. So it looks like that's been pretty successful. So, all right, we are less than a minute away from hitting transonic. Again, pretty soon our forward velocity is going to look like it's kind of falling off a cliff, and Starship will look like it's falling off a cliff as we essentially go into our belly flop. If you watch some of the high altitude tests or suborbital campaigns, we were able to test that. It was a pretty fundamental, like, can this thing actually fly? And we were able to prove that out with that suborbital campaign, and that's what we're about to see shortly here. All right, so at this point, we've dropped below the speed of sound, so Starship itself is subsonic. We are starting to chill the engines for a landing burn attempt. Landing flip supposed to start in a little over 2 minutes. Subsonic Indian Ocean, we're on our way.
Starship is subsonic.
There we go. Farewell, space. All right, so coming up in just a little under 2 minutes, so we're going to do the flip and the burn. So we're only using those 3 center Raptor engines, the sea levels, the ones that can kind of gimbal, that can move around and steer. Dipping the nose down a little bit. Got 2 of our engines chilled in, waiting on 1 more. So again, we'll attempt to use 3 burns for that initial flip. We eventually go down to just 2 Raptors for the end of the landing burn.
Just about 1 minute now from that landing flip and landing burn start.
Structurally, we're looking good. Got good pressures in our nose cone for everything. Just about 30 seconds. So again, we're going to look for the flip. So Starship's doing its belly flop right now. We're going to do the flip. Swing out. Let's punch through some clouds first. Here we go.
Starship landing burn startup.
Seeing 3 engines. There's our flip. There's a buoy. There's a splashdown. Hey.
成功了。
Oh man, yeah, farewell ship 37. Thank you, buoy cam. Landing flip, landing burn, splash out of the Indian Ocean. There we go. All right. That was pretty awesome.
Incredible flight
cool, right?
today for both ship and booster.
Yeah, really incredible. So obviously we're excited here. It looks like everybody's excited over there. Tyler, how's it going over in Hawthorne?
We are super excited here in Hawthorne. It was another exciting Starship flight test in the books, and we hope you enjoyed those Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed enormously to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that's going to wrap it up for us here in Hawthorne. Thank you to everyone for tuning in today. It was great being with you today. Back to you guys.
That was absolutely incredible. Huge congrats to all the teams here. Again, we lifted off from Starbase, Texas, right at the top of our window at 6:30 p.m. Central Time. We saw a booster successfully lift us up through ascent, had a successful hot staging where ship continued on with its suborbital trajectory. Booster came back down, had that boost back burn, and a successful landing burn with that unique engine configuration as well.
Yeah, and then ship continued on its way, made it all the way into space. We got to see first ever payload deploy.
So exciting.
That was awesome. We got the door open, 8 Starlink simulators deployed, relit that Raptor engine, and then on entry we probably gave it a little bit of extra time in the oven, but made it all the way through re-entry. All 3 engines started up, landing flip, splashed down in the Indian Ocean. Promised maximum excitement. Starship delivered.
Most
so
definitely.
Congratulations, all of our teammates here at SpaceX. It's been a year. Everybody that's worked on this program, this is what we're working for. So big congrats to all of them. Thank you to all of our future customers, too, for your support.
And we'd also like to thank the fine people of Cameron County, including the residents of its newest city, Starbase, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and the Australian Space Agency.
Be sure to stay tuned to SpaceX on X for updates, more of the views. This is just a tiny amount of the views. We have so many views that we didn't get to feature on the broadcast, so we're going to be going through that over the next couple of days, and we'll be posting it all there.
Yeah, if you're interested in more launch coverage, head on over to spacex.com/launches for the most up-to-date information. In fact, we actually recently rolled out a new departure board featuring our upcoming launches with details like mission name, launch and landing site, and liftoff time. So be sure to check it out.
All right. We just launched the world's biggest rocket. Again, dropped a couple satellites off, suborbital.
Incredible payload deploy for today.
Nailed that double header into the ocean, splashdown, time to go through the data. Really crazy cool to hit all those objectives today.
Yeah, huge shout out to all the teams who make this look easy. And thanks to all of you for tuning in, and we will see you back here for Flight 11. Good night.
好的啊，这个 reaction 看完了，我调整到一个我认为比较适合我这个头像的这个位置啊。应该说这也是一个堪称完美的里程碑式的这个巨大成功啊！这个我之所以放到最后啊，就看一下主持人他们自己的总结啊，这确实是不仅打破了从2024年10月份以来啊，这个长达接近1年的这个失败的这个魔咒，而且几乎所有的测试项目都获得了超过预期的这个结果。首先就是全程任务是一气呵成啊。这是第一次啊，这个星舰和超重啊，在一个完整的任务剖面里边，从发射升空啊，到分别在地球的两端降落啊，然后全部成功的完成了预定目标啊，标志着呢端到端的这个任务流程被首次完整的验证。第二个就是太空货运是吧？星舰在轨道上呢，首次打开了这个有效载荷的门啊，并且像这个发糖果一样，把8颗模拟卫星啊一颗一颗推向太空。这是前几次都没有实现的这个关键目标，这一次是完成了啊。所以呢，起码星舰作为一个卫星部署平台，它是有这个核心能力的。再一个就是在极限环境下这种惊人的韧性啊。这次这个整个这个任务的精华呀，就是 SpaceX 呢故意虐着飞船，让这个飞船呢承受极限的压力和热量，甚至啊移除了部分的隔热瓦进行测试。所以很多航天迷认为这个隔热瓦是 掉了或者怎么样都不是啊，都是就是故意的啊。所以飞船的襟翼啊，尽管是烧得很厉害但是呢，还是凭借这个强大的这个机载的这个系统啊，保持稳定，最终完成这个降落啊。最后到海面上那一瞬间，它是垂直的啊，完成了最终降落。这就是极大的证明了它这个设计的荣誉度和可靠性是非常高的，另外也非常坚固啊，纯不锈钢活。关键的就是这个 Super Heavy 啊，也在着陆过程中把它成功的进行了一次模拟引擎故障的这么一个极限测试，验证了系统的这个可靠性。而且星舰呢也在太空中重启了一次猛禽发动机，这在未来你比如说执行月球任务、火星任务里边，这都是必备的技能也随时需要调整。关键的还有一个就是依靠星链的技术就是 Starlink 技术呢 ，SpaceX 首次传回了这个穿越等离子黑障区的时候这个高清全程录像这在全球航天史上是极为罕见的，就给这些工程师提供了宝贵的数据，也给我们提供了极为罕见的，应该说无与伦比的这种视觉盛宴。所以这个 FT10 就是星舰的第10次发射，我觉得是一个 SpaceX 的星舰发射史上的一个转折点这不仅仅是重建信心的问题了，而且呢表明这个星舰项目从充满不确定性的这个实验阶段开始正式迈入了这种验证的这种可靠性和实用性的这个准应用阶段。那下一次可能就部署真正的卫星了，是吧？那如果能部署真正的卫星，它的发射的成本也会大大降低了。所以外界包括 NASA 包括这个登月计划阿尔忒弥斯这些这个信心会增强所以就像主持人说的一样，人类成为多行星生物的可能性就大大增加了。好吧，这就是今天马斯克的一个 SpaceX 的一个发射一个成功的发射，给大家做个简单介绍。谢谢大家收看，我们下次再见，拜拜。